Hello, my name is Marah Halawa, and I'm going to present our paper, Action-Based Contrastive Learning for Trajectory Prediction. This work is done jointly with Olaf Hilfisch and Pia Pido at Technical University of Berlin Science of Intelligence Cluster. Predicting the future trajectory of pedestrian is an important task in many applications, such as in autonomous driving. Therefore, in this work, we address the problem of predicting future trajectory of pedestrian in first-person view setting with a moving camera. Typically, the future trajectory of an agent or pedestrian is predicted based on its own past trajectory. In this work, we argue that when predicting the future trajectory of pedestrian, then limiting the information used for prediction to the past trajectory only is not sufficient. In those cases, additional information about pedestrian behavior, such as their current action, plays an important role for predicting their future trajectory. For example, the future trajectory of pedestrian who's walking while texting is on the phone could be different from pedestrian who is carrying an object or biking or pushing a baby stroller, even if they have the same previous observed trajectory and the same ending goal. Therefore, we introduced an action-based contrastive learning framework that encouraged the trajectory embedding of agents performing the same action to come closer to each other in the future space, and embeddings of pedestrian who's performing different action far away from each other. So we formulate the problem as following. For each pedestrian, we have as an input their own observed past trajectory as a sequence of bounding box coordinates and its own action during the observed time. We predict as an output for each pedestrian its future trajectory as a sequence of bounding box coordinates. Our proposed framework consists of two components. The first one is an action-based contrastive loss that's based on action-based sampling strategy, where for each observed trajectory called an anchor, for example, the trajectory of the biker here in this figure, we have multiple positive and negative samples. The positive samples are the trajectory that have the same action as the anchor, and the augmented version of the anchor trajectory as well. The negative samples are the trajectory belong to a different action class than the anchor. With n positive samples and k negative samples in the batch, we calculate the contrastive loss as following, where h is the trajectory embedding and sim is the similarity between those embeddings. The action-based contrastive loss played as a regularizer to the main trajectory loss. It's worth mentioning that pedestrian action class is only needed during training. However, during inference, the model only takes the observed past trajectory as an input to predict the future trajectory. The second component of our framework is a novel synthetic trajectory sampling technique. Due to the relatively limited size of trajectory datasets and the shortage of diversity in action class in captured scene, we need more comprehensive positive and negative samples. Inspired from the multimodality in the prediction space, we introduce a novel sampling technique to extend training samples by sampling from Gaussian latent space multiple times and pass those samples to a decoder to effectively predict different feasible future trajectory, conditioned on the observed input. This synthetic trajectory sampling strategy changed the sets of positive and negative samples used in creating training batch. However, the proposed contrastive loss remained the same. We evaluate our method on 3 benchmarks. Result on JAD and PI datasets showed that our method ABC Plus achieves superior performance compared to the baseline PI trap that does not use our action-based contrastive loss. Results on T10 datasets indicate that our approach ABC Plus of using action information by the action-based contrastive loss is more efficient than encoding the action classes in the embedding space representation as in T10AB. Those are our references, and thank you for your attention.